Hey there, pre-VCE Math goers, Taz here. I'm making this video as I'll be at the Werribee Zoo with my VM Unit 4 crew on Tuesday with Marnie, so I'm pre-recording this on Wednesday, the week before. So this video you should watch in conjunction with doing the set questions. We'll be looking into exercise 5E, quartiles and outliers. So by the end of this, it will be good for you to have the skill sets of knowing which statistics make up the 5-number summary system or 5 biggest summary, to be able to calculate quartiles, and I'll go into more detail what quartiles are, to be able to find the interquartile range and know what it is that it represents, to know what is meant by an outlier, and you've heard this term before, outlier, and to actually find an outlier through calculations, and understand the impact of outliers on various statistics. Why an outlier is sometimes considered good or bad, depending on what it is that a particular researcher or observer is trying to obtain. So there's a bunch of key vocabulary to look into, which you can look into at the bottom. Now, before I jump into the sheets, this can be found on Google Classroom. Hopefully you can go into Google Classroom, look for exercise 5E, find the relevant worksheet for board notes, print it out and stick it into your book. Preferably print it single-sided, or you can ask a mentor for any help. Now, while we look into quartiles and outliers, a really good example is house prices. And let's say, for instance, there's a particular family or a person who's looking for a new house in a suburb because they want to, say, live closer to work. Now, if they go onto a website like realestate.com or domain.com.au, anything equivalent, they'll be given information about how much certain house prices are, and then you can put it into a ranking system from lowest to most expensive house, and say they just choose a suburb or surrounding suburbs. Now, if this particular person were to get all of the house prices and put it from smallest to largest, and let's say there's about 20 different houses that are on sale, they all vary in prices, he will notice, or they'll notice, that there is some sort of pattern, or I guess themes that emerge. And you might see this as well if you go house hunting. I don't know if this is a thing that you might do, go into these websites and see what's out there for sale. I recommend that you do it, it's pretty cool. But there is a pattern that starts to emerge, or a theme. The lower end price houses, they are cheap for a reason. Generally that reason is you might need a bit of maintenance, or the size of the land is quite small in comparison to the other blocks that are on sale. And then on the other end of the spectrum, so the really expensive houses, obviously they're expensive for a particular reason as well. The land size might be much bigger. Maybe there's more rooms, more garage spaces, or maybe they're closer to particular amenities like shopping centers or schools, or fire or police. There's a whole list of reasons that dictate the fluctuations of house prices. Now, when you are looking, or when this particular person is looking for a house, maybe they tend to gravitate towards just the middle group of prices that's deemed comfortable. This is called the middle 50%. Okay, maybe you can narrow it down to maybe the middle 40 or middle 30, but generally speaking, the houses of interest for this particular person is that middle 50%, because they don't want to go into both ends of the spectrum unless they're really cheap or they have a lot of money. But for the majority, or the general population, they'll be honing in on that middle 50%. That there has a special name, and it's called the interquartile range. There is a way that you can work it out mathematically, and that's what we're going to be exploring today. The other ends of the spectrum as well, sometimes you might have a really cheap house or a really expensive house that seems really out of place in comparison to the other house prices, for this example anyways. Those are called outliers. And again, there is a way that we can figure out mathematically how to find out what those outliers are, and if it's considered an outlier. Sometimes it might not be, sometimes it looks a bit deceiving. We'll have a look into that. So the 5-figure summary or 5-number summary system that some textbooks look into, it's a list of 5 important features of numerical data. This includes the minimum value when ordered from smallest to largest, the lower quartile, considered Q1, the median, also known as Q2, and the upper quartile, Q3, with the maximum as the last value. Now, all you're doing is chunking up a set of numerical values into quarters. And depending on how many values you get, not only does it determine or look into odds and evens, there's more that goes into play with this. You chunk them up into quarters and you're just going to look for either 2 or 1 singular number that's in the middle. So let's take, for instance, this array of numbers. You got your Q2 as a solo number, and then it's split into 2 parts, the first half and the second half. When you have one solo number in the middle, that's considered your Q2, for now, to try to look for Q1 and Q3, you omit it. And omit just means place aside for now. The 5 here isn't included within this first half or within that second half. Now this changes in the other example, which we'll look into in a second. We'll look at the first half. There are 4 values, which is an even amount. So we know that we're going to get the middle of the 2 middle numbers, which coincidentally happens to be 2. Same again with 6 and 7 for the second half. This is our Q3. This will be the middle, which is 6.5. So our Q1 and our Q3 are middle set of values, ranges in between 2 to 6.5. Pretty easy to find the quartiles. It's just a matter of splitting numbers up. Now, if there are even amount of number in the data values, remember to get your Q2, it's finding the average of the 2 middle values. But right now we don't do any omitting of any sort. The 7 is included on this side and the 8 is included on the other side. Then from that, you will get a situation, just for these particular numbers anyways, where you will have a middle number, which is 3, and a middle number, which is 9, and that will give you your Q1 and your Q3. Now, there are going to be different scenarios depending on how many values there are. Even and odd do play a role just for median, but then there's also different types of even and odds. You can get a set of middle numbers where you have to get the middle of those 2 middle numbers. Then you might have to get the 2 middle numbers for Q1 and the 2 middle numbers for Q3. Or you'll have this situation here. There are other situations where you have a middle number for Q2, middle number for Q1, middle number for Q3. It really depends on how many numbers there are, so just be careful about that. Now, how you get to IQR? You find the difference between Q3 and Q1. It's always Q3, take away Q1. Outliers are data elements outside the vicinity of the rest of the data, and it's considered quite outside the realm. So a data point is an outlier if it is less than what we call the lower fence. Now, to work out your lower fence, you get your Q1 and you take away, and I'll put this in brackets, 1.5 lots of the IQR. Now, 1.5, where does this number come from? There's a lot of research that goes into finding this particular number, and it has to do with a thing called deviations, but we won't get to that right now. Once you find that out, you'll get a number. Anything lower than that is considered a low outlier. Then on the other end of the spectrum, if you find Q3 and you add 1.5 lots of the IQR, anything higher than that, or greater than that, what's called the upper fence is also considered an outlier as well. Generally speaking, you're going to find more outliers in the greater than the upper fence than you will the other way around. Again, it really depends on the data that you get. And outliers significantly affect the range of a data set, but have limited to no effect on the actual IQR itself. So in the next video, I'll show you how to tackle the examples from the notes that I've provided. This here is an explanation. If you feel confident and you don't need to go through the examples, you can have a look at the questions, which I'll show in the next video regardless. Or it's on the bottom of the sheet that should be printed out. All right, if I see you in the next video, catch you then. If not, enjoy your questions and I'll see you next time in class.